Well, let's look at this rational equation right here, rational function 2x squared minus 5x plus 2 over x squared minus 4. And this example is going to help us to have an idea of what happens when there's a hole in the graph and how do you identify if there's a hole. First thing we'll do is usually factor them down. And in this case, you see that we do have some factors that eliminate. Before I do that, I do want to make note of what my domain restrictions are. I will still have some domain restrictions even though we canceled out this x minus 2. So all x such that x does not equal plus or minus 2. Those are my domain restrictions. Now as we start to graph our function, we remember that where the numerator factor becomes 0 is where we have a solution of the graph. So I have a solution at the point x equals 1/2. Setting the numerator equal to 0 produces x equals 1/2. The denominator tells me where I have a vertical asymptote at. And I have a vertical asymptote at the point x equals -2. That's where the graph is undefined. Well, you also remember too that the graph was also undefined originally at the point x equals 2. Well, since there's no vertical asymptote there, but that is where the hole will be at. I have to make sure I exclude that value from the graph. The next part of the graph that I want to do is determine is there a horizontal asymptote. So I'm looking at the coefficients of the degree of the leading coefficient terms, or the degree of the polynomials. I have an x squared over an x squared. It's the same, which means I will have a horizontal asymptote at a line, y equals something. And to determine where that line will be located at will be the ratio of those leading coefficients, 2 over 1, or at the point line y equals 2. I also want to find out at that line, does the graph cross or pass through that asymptote at any point in time? And to figure that out, I will take my function and set it equal to 2. Whoops. Set it to my function. I reduced my function down, so I'm using that one. And I see that 4 equals -1, which is a false statement. So therefore, I do not have a place on this graph that will pass through that asymptote. So there's no pass-through. My graph also too, I can also determine where it crosses the y-axis at. And it crosses the y-axis at the point -1/2. The point where does r of x equals 0 at, and it equals 0 at the point -1/2. Plus 2 over -4 makes it -1/2, so right down there. Well, now I have enough information to graph this graph. I'm going to look in region 1 and region 2. Well, I have an idea in region 1 what the graph is doing. The graph, there's no x solutions over here, so I can't have any graph underneath this asymptote. The graph must therefore be above in that upper section. In this middle section, I see 2 points it goes through, so I know the line graph has to cross through those points. And then it also is approaching those lines asymptotically. And so there's the graph, with one minor exception. Remember, the point x equals 2 was undefined. So right here at 2, I have a hole in the graph. And that's to designate that it was also a value that had a domain restriction.